In this session, we will look at what are the different ways of visualizing the data distribution. So we'll look at different kinds of charts like circle charts, jittering, box plots, histograms, etc. So we are not looking at one single value of the data, we are looking at how the data is distributed. See, many a times, if I am computing a total or a part to a whole computation, we get only a small piece of information of the entire data. We really want to see where a particular item falls relative to the other item. Vis-a-vis the other item, where is a particular item falling? Like, where does a particular student's marks lie vis-a-vis the other student's marks? Is he on the higher side or on the lower side or somewhere close to the average, above average, below average? So in a distribution of the entire marks of the student, where does the particular student's marks lie? Similarly, sales, okay, in comparison with the other region sales, where does the sales of the particular region lie? So we are looking at a distribution of all the values and one specific value in that entire distribution. So those are kind of charts, those are the kind of visualizations which can be accomplished through the circle chart, jittering, etc. So what we are trying to understand here, how a particular individual item is compared with respect to each other. And so which means here some of the things, the item which we are talking of, the individual, generally it's a dimension, right? It's a dimension and it has a very high cardinal value. Means the number of individuals is very high, right? Number of distinct students is very high. Number of distinct regions of sales is very high. And I really wanted to compare a measure across all these individuals. Like I wanted to compare the marks or I wanted to compare the sales. Now this is where I can use the charts associated with the distribution. So here we'll see how we create these kind of charts in Tableau. So the first of this I'm calling as a circle chart. So circle chart is actually helping us to visualize a distribution. So probably if I really want to see within each market or for each product, if I really want to see how each state or how each region is doing vis-a-vis the others, I can very well use the circle charts. Let's look at this. Let's say I'm using my copy chain example. Okay, in copy chain, okay, we have an area code, fair enough. Or a state is there. Right, so let's say I want to look at within a particular market, right? So let me drag the market into the rows. So obviously I am seeing central, east, south, west. Okay, within each market, I really want to see, okay, if I say I want to see just the profits, or the sales, whatever it is, I can simply drag the stuff here. Okay, what right now comes is a simple bar chart. But from this automatic, first let me change it to a circle. Okay, corresponding to each of these four regions, I have got circles like this. But if I really want to look at a distribution here, what we are simply saying is, now I'm not looking at one single value. Okay, central, I know this is the profit. But I want to see within the central, what is the distribution of profits of all the centers, of all the area codes. Right? I want to look at the distribution of profits of all the area codes, because I want to see within the central market which area code is doing the best, which area code is above average, which is below average, etc. So that is where I really want a level of detail. Now what I can simply do is the area code I'll drag into the detail. The area code, okay, otherwise let me drag the state. Oh, it's not able to communicate to the data source. Okay, let's do it product wise then. Right, okay, we will do it product wise. So what is that we are doing here product wise? Okay, this is the central. Within this central, each of the product is generating this level of profit. So there are some which are generating much lesser profit. There are some which are generating a very high profit. Probably I could see here within the central, the cafe mocha and chamomile are generating very high profits, whereas green tea is generating a very low profit. Similarly, within the East, cafe mocha is actually is generating a big loss, whereas regular espresso is generating the highest profit. Similarly, in the or probably in the East market, Colombian is the highest profitable product. Similarly, in the South market, probably something like this, lemon tea ends up to be the least, Colombian ends up to be the highest profitable product. In the West, again, green tea is the least profitable product, whereas the lemon tea ends up to be the most profitable product. So I can very well see market wise what is the distribution, right? So I have dragged that. Now what I can really see is which products are above average and which are below average. So this is where I can really click on this profits axis, right? And I can simply say add a reference line. When I say add a reference line, here I can talk about whether I want to add a line or a band or a distribution or a box plot. Now if I add this, it becomes a box plot. We'll come to it in the next step. But otherwise, I can simply add a reference line which talks about the average. And I will add it not for the entire pane but for each cell. Means for one average per central, one average per east, it comes like that. So I'll say per cell, and the value is based on the profit. Right? Based on the profit, I can very well add the average line. So I can go with the average, and the average line would be added per each cell. And I can do some kind of formatting for that. Right? If I want only the line, I can plot line and the confidence interval. If I want 95% confidence interval, I can plot that. And any kind of formattings and all, if we want, we can very well bring those kind of stuff. Right? We can use this kind, we can use this kind. So filling the above, filling the below with some colors. If you really want, you can bring all that kind of stuff. Okay. And now we can also talk about having a different color probably for each of the region. So what I could do, the market, again I pull on the color axis. So I'll get different colors for each. Okay, what I am clearly seeing here is, okay, in central market there are some which are below average, above average. Same goes with each of the markets, right? So this is how a circle chart simply looks like. It's quite simple to plot, right? You just need to identify on one dimension and a simple breakdown within that particular dimension, the distribution of all the individuals. The distribution of all the individuals, and you should clearly see which value is lying where. So which product is more profitable, which product is less profitable, such a kind of a distribution you can very well obtain. Then you can very well obtain such a kind of a distribution. Then if I am more interested in a box plot, right, just an extension to the circle chart, I can go with a box plot. So generally we call even this kind of a chart as a box whisker plot, because they provide slightly additional information and primarily the context to the distribution. So apart from just drawing that average line, they are going to draw the upper and lower quartiles. So upper quartile is the 75 percentile of the values. Lower quartile is the 25 percentile of the values. So it is showing the middle 50% of the distribution. And along with that, it also plots the whiskers. So whiskers typically are like this: upper quartile plus 1.5 times interquartile range, and lower quartile minus 1.5 times the interquartile range. Either this would be plotted, or maximum this side, minimum this side would be plotted. So purely to identify the outliers present in the data. Which data points are very close to normal? Any data point lying within this region, we say they are close to normal. And any data points which are outside this region, we say they are abnormal or outliers. So that's the reason, that's a simple differentiator with respect to box plot. Now let me rename this sheet as circle chart, and let me duplicate the same sheet. Let me duplicate the sheet and this time name it as box plot. Now the only difference that I need to do is right click on the axis here. Again I am adding the reference line, or probably I could have edited because it was already present, or I remove the reference line and freshly I add a reference line, but this time I select the box plot, right? So whiskers, it is saying plus or minus 1.5 times the interquartile range, and hide the underlying marks except the outliers. I wanted to show only the outliers. If I don't show it, all the data plots will be shown. We'll see both of them, and some kind of formattings and all it is asking us. Write the filling, let it go with the default, otherwise you can very well go ahead and make the modification. Now this is what it is showing. So the whisker, you could see here, the upper whisker is to the extent of 14,642, the lower whisker to the extent of 1,227, the median, the lower quantile, the upper quantile. Anything outside this region is an outlier. So probably if I really want to do this exercise again, I'll do an edit reference line, but I say hide underlying marks except the outliers. Now I'll clearly see which are the outliers. So here I am seeing that in the East market, Colombian has a very abnormal kind of profit compared to normal. It's an outlier kind of a profit. It's not in the normal zone. It has gone very much extraordinary. So such a kind of interpretation can come very comfortably when we are using this box plot. Very useful chart to identify the outliers present in the data, right? So you could very much again edit the reference line. Let's say if I want to show all of them, and okay, I'll say classic, filling, some kind of modifications you can very well plan out. So this is what it is telling you, and the same circle chart, probably instead of just putting one single line, if I am putting a box plot like this, it can really give me a good indication of the various outliers that are present in my data. Now the next one which I should look at here is the concept of jittering. Now it is also built on the top of the circle chart. So let me simply duplicate the circle chart again, right? Calling it jittering. Now when do I really use this? See, many a times when we are doing a circle chart, and probably if the number of individuals are too high, it might very well be possible that the marks are overlapping, right? These plots, they may overlap on each other, and they may not show. Because of that, the true story may not come out to us. It might so happen, okay, this is one, I mean visually this is looking like one, but it could be very much possible that two of them are overlapping and we were not able to differentiate that. Now that is what is one of the problems that could be associated with a simple circle chart, right? So to address this, we are talking about jittering. Especially in a circle chart, there is a possibility that one circle can overlap the other, which could result in obscuring the total story for us. So that is the area where jittering is trying to address. So this is a kind of a technique, especially in data visualization, where we are adding some kind of intentional noise. We will add some kind of intentional noise to the visualization with a very simple intention that we are not disturbing the integrity of the communication. We are not disturbing the integrity of the communication, but we are trying to add some kind of intentional noise to the data visualization. Now, what are we simply doing? Here we go with a process of a simple calculated field, and we are calling that calculated field as index, and probably we are using the index function itself. Now what does the index function do for us? So it is like an auto increment, right? So 1, 2, 3, 4 for each intersection of the dimension value with the partition of the view, within a partition of the view, it actually increments by a very small value, right? And by increasing by a value of 1, by changing it by a value of 1 or by some index number, it may not impact the whole story at all. Now, what we'll simply do, once we do it, we get a clarity. Now, what for the same, we will create a calculated field. I go into analysis. I say create a calculated field. I'm simply calling this as index, and I'm putting nothing but I'm using a formula called index. That's it. Right? I have simply created a calculation called index, which is nothing but it adds a serial number kind of stuff. And I could see that index is something that got created here. So I'll simply take this index from here and I'll put it in the rows. Now I am seeing a clear-cut difference. For each of them, there is an index that got created, 0, 1, 2, 3, 4. So for each of them, there is a separate indexing that came up, and each one is differentiated very clearly out here. And when I'm going with the drop down for this index, I really want to see a few things out here. I really want to see a few things out here. I say compute using the product. So I say this index need to be computed based on the product. Okay. So there is for each one a separate number is coming out now. 0, 1, 2, 3, 4, the index for each of the ones. There is a separate number and it's a serial number. Actually, it has no meaning as well. So I really don't want these headings to be displayed. So I right click on this and I simply say show header. I remove the header. So I'm getting a very clear cut picture now. Instead of they overlapping on each other, I'm very clearly seeing that they are at one point up because there is an index that is created for each of them. They, instead of being created on one single line, see, when the index was not there, one market, one single line. But when the index is nothing but it's a serial number. So the serial number for each product means, so 1, 2, 3, 4, 5 is existing for each of the products. So what has happened? We have taken that in the rows. So there will be a separate row for each individual, right? So whatever is the overlap, now it will not be an overlap at all because there is one more layer that is there in the plotting, which is the index. Of course, we are not showing the heading of the index because there is no meaning and it does not convey anything. So I have removed the heading part, and probably even these grid lines and all also I can very well remove. So basically I will go into the format and I can play around with the stuff, especially with the lines, right? Okay, there are so many things that it is talking of. So in the rows, I don't want the grid lines, so I'll say none. Probably if required, I'll keep them in the column, fine. So now it is giving me a clear picture. The average in central is slightly higher compared to that of east. South is more or less similar to that of east, and west is more or less similar to that of the central. And you could see different products towards the left and towards the right. There are 2 to 3 products in the east which are not profitable at all. Again, another 3 products in the west that are not profitable at all. So the vertical grid lines, I may still keep them, but the horizontal grid lines, I may not be interested in having them, right? And to look at it slightly in a bigger manner, I can very well expand it so that I can look at the chart slightly more comfortably. Right now that I have the space, I can look at it more comfortably. So this is the true picture of the distribution. So this is the jittering process. I can actually apply it with a circle chart or for any, especially where I am looking at the plots, where I am thinking that the plots might overlap. I am thinking of avoiding that kind of an overlap by creating some kind of a differentiation between each of the plots by using this kind of a numbering mechanism. So we have indexed each of the product within each of the markets. So it's a continuous, first of all. Because it's continuous, it is defining the axis. And because of that, and that too because it's a serial number, all the values are distributed uniformly in a vertical zone. So in each individual mark can be very clearly observed, no overlapping occur, which means there is a higher level of confidence that you are not obscuring the total data. Right? That's an advantage that jittering is bringing to our data visualization. Another important aspect when we are trying to visualize our data. Then comes one more important product. Okay, we'll save it later. Then comes one more important chart, which is the histogram. So it's more like a bar chart, looks like a bar chart, but this is more talking about the frequency of the occurrence of values. Right? This simply talks about the frequency of occurrence of values. So the values would be there. So probably here I again want to look at the distribution of, let's say, the sales. Right? I want to look at the distribution of sales. So between each range, what is the number of sales of each ID? I want to look at what is the distribution of the sales, and this really helped me. I mean, once it is plotted, we can typically look at it. So that makes things more easier. We'll create a new, which we rename as histogram. Now what we do here is I really want to find out for the sales what is the kind of a distribution, right? Now for that, first of all, I really need to identify the range. So I'm taking a measure field which is more numeric. I create what we call as bins for it. Bins are nothing but grouping of values, right? Between 0 to 100, 101 to 200. So these are the bins. So for any numeric field, I create a kind of an interval like that, which I call as bins. So let's say I want to do it on sales, right? We right click on this, we create bins for this sales. So right click, bins. Now, okay, let me reconnect it. Right, looks like the connection is lost. All right, here let me look at the profit. I create bins based on the profit or sales. Probably let's do it on sales. I create bins. Now, okay, I'm calling the field as sales bin, and the size of the bin, it is showing 34.3. Otherwise, I can enter a new value. Okay, it has suggested 34.3 because the minimum value is 17 and the maximum is 912, and the difference is around 895, and there are 432 distinct values associated. So based on the calculation, it has identified, let's say the size of the bin is 34.3, which means it is like 17 to 51.3 will be one bin, and so on. It goes in that particular manner. Now, okay, we say, okay, so these are the bins that got created. So it's a grouping of all the measures. So that's the reason the sales bin became a dimension, because it has grouped all those sales which were between 17 and 51.3, and probably from 51.4 to another 34. They are all grouped into one single group, and because now they are distinct groups, we are talking about them as bins, which is a dimension. So that's the reason the bin came as a part of the dimension field here. Now, what is that I really want to count? So I really want to count how many records are there in each bin. Right? Let's say I want to count how many records are there in each bin. So what I do this sales bin and I put it in the column. Okay, now the rows are 0, 34.3, 68.6. So there is a grouping of 34.3 that is being done, and it goes even up to this 891. So that is the kind of a grouping that the sales bin came out with. And I really want to find out how many records are there which are falling in each of the category. So I'll simply drag the number of records here. Now I am getting a kind of histogram. What is that it is saying? Within that 0 to, right, within this 0 to 34, there is number of records, there are 30, and 34.3 to 68 something, the number of records are 468. So probably it is showing that majority of the sales have occurred somewhere around 102.9 to whatever 34 extra, but very high value sales are very less in number. So it's showing some kind of a distribution for me, again for each individual product. It's for total. Now I can really differentiate this as well for each of the products also. If I really want to bring more and more details into it, probably I say for each of the products I can still differentiate, right? So I can say for each of the products or whatever, I can differentiate and try to bring out product wise. So here I am simply looking at the total sales wise. Or if I want to see total different number of customers or something, or total different number of products, I can very well drag those kind of elements out here. So this is how a histogram is getting created. It's very useful in catching the anomalies. Oh, this is probably there are 8 sales which have happened close to 900 bucks. Very high value sales, right? So we are looking at the distribution of the sales by taking the sales on the x-axis, and the height of each of the bar shows the number of records which are there in my data which are having sales in that particular region. So when I am talking about any typical distribution, it should have a typically recognizable kind of a curve. Like some sales should be much of lesser value, some to be very high values, majority of them in the middle. Some such kind of recognizable pattern should typically come out with them. And they are very important tool in really understanding the anomalies or outliers that are present in our data, extreme values that are present in our data. So you can simply create them. I mean, one is this way where the histogram gets created, or a simple way of even looking at the histogram. Right, a simple way of looking at the histogram is you select just the line, you select the field. Let's say I want to create a histogram based on the sales. I simply select the sales, go to the show me. I have a histogram out here. I select the histogram. Simple. Automatically it creates a histogram for us. So by default it is computing a bin size. If required, we can very well adjust the bin size, because I can very well go into this sales, create my own bins. Instead of 34.3, now I can make it to any number. So based on the bin that I am identifying, again the chart will update accordingly. So it's a very simple mechanism which helps us in terms of understanding the distributions present in the data and pattern of the data. So all these circle chart, jittering, box plots, histogram, they really play a very important role in making us understand the distributions of the data. They are not looking at just one single point of the data. They are looking at the distribution of the entire data. All right. So thanks a lot for listening to this session. Thank you very much.